Hello everyone, my name is Fabien Caron. I'm the product manager for Raman technology in the Process Monitoring Solution Group. As we know, PAT tools are more and more used in order to ensure the good quality product in upstream and downstream processes. Today, I will be happy to talk about Raman technology, that is one of the main PAT tools in order to monitor your critical quality attributes and critical process parameter in your bioprocess. Raman spectroscopy is an analytical technique that is used in order to capture the chemical compositions of your samples, medium or cell cultures. This technique is based on light-matter interactions and more specifically in light scattering phenomenon appearing when vibrations of molecular bonds take place under light irradiations. So let's consider a samples with different molecules A, B and C in aqueous solutions, or even your cell cultures with metabolites as glucose or lactate, or even proteins or amino acids. When an incidence monochromatic light will interact with these molecules, a part of the light will be scattered with different energy depending on the chemical differences between each molecules. This scattered light will be then collected, analyzed and translated into spectra through the Raman analyzer. Spectra 10 will then provide to the scientist a full pictures with the fingerprint of each molecule inside the samples or the cell culture. Thus, a qualitative analysis of the sample or the cell culture can be undertaken by the scientists or bioengineers thanks to the Raman effect. So now, let's assume that we will add a certain amount of the component A continuously to our samples, or even to add the glucose continuously to the cell cultures. Interestingly, the Raman signal will increase proportionally to the concentrations of the molecule A, or in the case of the cell cultures, proportionally to the glucose. This will allow to the scientists or bioengineers to have a real quantitative analysis of each molecule present in the samples, in addition to the qualitative analysis that was done before. Actually, Ramans appear to be the technique of choice in order to understand, optimize, monitor and control CPPs and CQAs in your bioprocess applications. So this is due to the advantage of Raman that we previously mentioned. First, it has the capacity to capture the entire chemical compositions of your cell cultures in one spectrum. Second, it's a highly selective technique. Each molecule provides a well-defined spectral signature. Third, it's a quantitative technique. The Raman signal is proportional to the molecule concentration. Last but not least, one of the main advantages of Raman is that water will have a low effect on the spectra in your cell culture. In addition, Raman spectroscopy provides technical advantages. First, it's allows in-situ measurement, and so real-time monitoring of CQEs and CPPs of your bioprocess applications. Second, it is easily implementable in any process, thanks to the inline probe and also to the significant optical cable lengths, more than 1,000 meters. It is also a non-destructive technique, which ensure a good product quality, and finally, it does not require any consumables. To summarize, the Raman technology can be used as a qualitative or quantitative techniques in order to monitor or control CQA and CPPs in upstream or downstream processes in real time. However, quantitation is not direct as expected and requires chemometric approach in order to extract the information from the spectrum. So let's follow us to learn more about chemometrics in our next episode.